Hello friends, myself R.D. Mahajan presenting my video on application or use of duplication formula. Let us solve the problem. Evaluate integral from 0 to infinity dx divided by 1 plus x as to 4, and to evaluate it as it involves the term of a plus b in the integrand, we have to use the substitution b is equals to a tan square theta. Standard substitution. Here the value of b is x to 4, value of a is 1, tan square theta. This is the substitution. Taking square root on both sides, we get the value of x square as tan theta. Then differentiating it with respect to x, we get its differentiation as 2x dx is equal to differentiation of tan theta is secant square theta d theta. As I have used the substitution, we try to find out the new limits. When x is 0, for x is equals to 0, we get tan theta is equals to 0. Means theta is equals to tan inverse of 0, and tan inverse of 0 is 0. For the second value, for x is equal to infinity, we get tan theta is equals to infinity, theta is equals to tan inverse of infinity, and the value of tan inverse of infinity is pi by 2. If we call this as equation 1, substituting all this information in equation 1, that equation 1 becomes, we call that value as I suppose. Limit 0 to infinity, we have the new limits at 0 to pi by 2. The value of dx is secant square theta divided by 2 root of tan theta d theta, and divided by 1 plus x as to 4, but value of x as to 4 is tan square theta. Okay, and therefore it is 0 to pi by 2. Secant square theta, as it is no change, root of 2 times root of tan theta, and 1 plus tan square theta, standard trigonometric theta, it is secant square theta and d theta. So that this secant square and secant square theta get cancelled, we have 0 to pi by 2, yes, 1 by 2 times 1 upon root of tan theta. If you transfer it to numerator, it becomes root of cot theta, and then root of cot theta. Cot nothing but cos by sine, and therefore it becomes 1 by 2 times integration from 0 to pi by 2. It is root of cos by sine, cos theta by sine theta, and d theta. That is equals to 1 by 2 times integral from 0 to pi by 2. It is sine theta raised to minus 1 by 2 if you transfer to numerator, and into cos theta raised to 1 by 2 d theta. We call this as equation 2. And then to evaluate this integral, we try to apply reduction formula in terms of beta gamma function, with the value of p as minus 1 by 2 and the value of q as 1 by 2. Applying that formula. Using reduction formula, we know that integral from 0 to pi by 2 sin theta raised to p cos theta raised to q d theta, and that is equals to 1 by 2 times gamma of p plus 1 by 2 into gamma of q plus 1 by 2 and divided by gamma of p plus q by 2 and plus 1. Already I have discussed in my last video. Refer that video. Link I will provide in the description box. Therefore, applying this, we get it is 1 by 2. This 1 by 2 gamma of p plus 1 by 2. Therefore, it is minus 1 by 2 plus 1 divided by 2. Gamma of q plus 1 by 2, 1 by 2 plus 1 divided by 2 and whole divided by sum of these two, minus half plus half, we get 0. 0 divided by 2, we get 0 and plus 1. Simplifying it further, this 1 by 2 and 1 by 2, we get 1 by 4. Gamma of 2 minus 1, that is nothing but 1 by 2, and divided by 2, that term becomes 1 by 4 in simplified form. 2 plus 1, we get 3 by 2 divided by 2 means it becomes 3 by 4, and the value of gamma 1 is 1. And then to find the value of this product of gamma 1 by 4, gamma 3 by 4 using duplication formula, we know that gamma n, gamma 1 minus n as pi upon sin n pi. With the condition n is in between 0 and 1. Therefore, if we consider the value of n as 1 by 4, here n is equals to 1 by 4, which is in between 0 and 1. The value is in between 0 and 1, and therefore 1 minus n becomes 1 minus 1 by 4, 4 minus 1, that becomes 3 by 4. And therefore, applying this, we get 1 by 4 as it is. The value of this product of two gammas by duplication formula, it is pi divided by sin of n pi. The value of n is here 1 by 4, therefore it becomes pi by 4. It is 1 by 4 pi. The value of sin pi by 4 is 1 by root 2. We get that simplified value as transferring this to numerator, it becomes root 2 pi divided by 4. 4 is nothing but 2 square. Therefore, it is root 2 pi divided by, it is 2 square. 2 means root 2 into root 2 and its square. 2 root 2 remaining, and therefore this is the value of that definite integral 0 to infinity dx divided by 1 plus x raised to 4. In this problem, I have used two important results. One is the reduction formula in terms of beta gamma function, and the second one is the duplication formula. Therefore, as we are using these two important formulas, this problem becomes the important one as per the basic concept. Two important concepts we are using here. One more I will discuss in my next video. If you like my videos, please share it as well as subscribe to my channel to get a notification for my new videos. For that, you have to press the bell icon. Thank you.